Page 206, number 49. Find all the zeros of the function, finding exact values whenever possible. Identify each zero as rational or irrational. All right, so how you start this is we're going to do this without a graphing calculator. We are going to first list all possible zeros. We're going to start with rational ones. And so how we do that is we look at our constant and our leading coefficient, and we're going to list our p's and q's, which are the factors of those two numbers. So p's all come from the constant, and q's come from the leading coefficient. Okay, so to list all the factors, remember they could be positive or negative. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So we can get 6 by multiplying two of those factors together. So for q, we have 2 as the leading coefficient, so our q's are just going to be plus or minus 1, plus or minus 2. Since it is a prime number. Then what we're going to do is we're going to find our possible rational zeros by taking those factors of p and dividing them by each factor of q. So starting with 1 for q, if I divide 1 into all of my p's, I get my p's back. So I'm going to list those. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now what I want to do is take my q, my value of 2, and divide it into each one of them. And I'm going to list any that are different. So if I take 1 over 2, I get a half, so that's different, plus or minus a half. And then if I divide 2 by 2, I get 1. I already have that one. If I divide 3 by 2, that's a new one, so I get plus or minus 3 halves. And then finally dividing 6 by the 2, I get 3, which I already have. So there's all my possible rational zeros. So that's where I want to start. So the next thing I want to do is I want to use the factor theorem to find a zero. And this is going to give me a rational zero. So what the factor theorem tells us is that anytime I substitute a value into the function, if the value of the function is 0, then I have found a zero. So the quickest way to do this is kind of a guess and check thing, but you're going to substitute either positive or negative 1, positive or negative 2 into the function and see which values will give you 0 for the function value, for the y value. You can do this using synthetic division if you want, but I think the fastest thing to do is to pick up your calculator and do them very quickly in the calculator. So I did a couple, but the first one I found was 3 over 2 was the first one that worked. So I'm going to show you what this looks like. So let's say this was the first one I tried. And so I put that in the calculator. So if you notice, I replaced x with 3 over 2. And if I hit enter, what happens is I get a value of 0. So by the factor theorem, that tells me that I have found a 0. So here's how we use this then. So what we want to do then is we want to use synthetic division, and we're going to divide out that factor out of our polynomial. So we're going to do 3 over 2, and we're going to list the leading coefficients, or not the leading coefficients, all the coefficients. So we have a 2, and then we have a negative 3, we have a negative 4, and we have a 6. So we're going to go ahead and we're going to divide that out. So we bring the 2 down, then we multiply and we get 3. So we get a 0 here. And then we multiply, we're going to get a 0. Since we're multiplying by 0, we bring the negative 4 down and we multiply negative 4 times 3 over 2. We get negative 6. And this is another check. We should have a remainder of 0, which we do. So that's another check just to make sure you didn't make a mistake in your calculator, that we do have a 0. So now, here's what our polynomial looks like. Our polynomial now looks like this. We have our factor of x minus 3 over 2, And what is left of the polynomial is 2x squared minus 4. And what we want to do then is we want to set that equal to 0. Now the nice thing is because this is a quadratic, we can use a quadratic formula. We can factor it if possible. But then one thing I can do with this is I can just solve it using square roots. So I'm just going to take 2x squared minus 4, set that equal to 0. So I get 2x squared equals 4, x squared equals 2. And so my other two zeros are going to be plus or minus the square root of 2. So I have found all the zeros. So I'm supposed to identify them as rational or irrational. So that's our final step. So step 3 is to list the zeros. So our first one is x equals 3 over 2, and that is a rational 0. The next 0 is the square root of 2, and square root of 2 is an irrational number. And then the final one is negative square root of 2, which is also irrational. And there we have all of our zeros, and we've identified them.